Hi and welcome to this training video. I am Kenneth and I'll be your guide on this tour showing you how to do OPC UA connectivity in ReportLoq. The first thing you want to do when doing this is to start up the ReportLoq UI. You can do this on the icon on the desktop and this will generate the graphics that I have here. You do the configuration for each stack or line in your database or setup. So you need to press the line here and press edit. Whenever you enter this dialog, then you can change the data source. This one has currently the value generator for testing enabled, which means that the data system is currently just generating these ramping values and displaying them. We can also see here that it is being displayed on the web server and the data export is currently running. So let's just do a brief verification that that is actually true by entering localhost and seeing that the data here is actually changing every 10 seconds where the data locks the data or the system blocks the data. And we can see that everything here is in test. There's no other way to do it when you are generating test values. Notice that the data here, well, it just changed. It's just generating these sinus curves, and that isn't really that interesting. We want to try to connect it to a OPC UA server instead and retrieve data from there. So I have a server, and I'm not going to go through that, but I will show you that I have a OPC UA client here installed, and that I have these 3 data points that are currently pending that I'll be using for this demo. One is generating test values, and I would like to enter that test value so it'll be changing in this data range from 0 to 300 erratically. We can also see that it is located in namespace 4, so we'll need to take that into account, and we'll try to put it on the CEO and nothing else. We'll also try to validate the CEO's signal using this Boolean, which is high, which should mean, in my case here, that the signal should be invalidated, so it's not good. This is indicating an error on my CEO. The output value here, which is static to 0, should be the calculated value for the CEO in a qual2 state sent back into the control system. So we want to take this particular value and send it back to the OPC UA server. Yeah, so let's do that. We enter the setup for the stack here, and we change it to the OPC UA server, and it asks for an IP and a port separated by the colon. I have one in my clipboard ready. This is my OPC UA server, and I'm using a random port or a custom port for my OPC UA server. This is typically 4840 for OPC UA servers. Whenever you've entered that and press connect, the system will connect to the OPC UA server, as you can see it did here. If it didn't work, you'll get an error message. But we can see that we are actually connected, so everything's okay for now. Data has stopped flowing. It did when we changed the endpoint. So the graphic here in the background will eventually turn very red, indicating that there's something wrong, data is missing. The CEO, or the table here to the right, contains all the emission components in the same order that they're listed in the graphics. And we need to put something into the fields that are orange. It's possible to put something into other fields as well, but the orange fields are definitely a requirement for the system to work properly. This particular column, the node ID value, will contain the value for the CEO here. So we want to take a value from the OPC server and put it into the CEO, and if we do that, then it has to go into this particular field. As we can see here, let's just drag these down a bit. We want to take this one, the changing one, the input one real, and put it into the CEO data value here. So double click in the field and input And notice this is case sensitive. Input 1 real. This is the name from the node ID. And the namespace number 4 has to be appended with a hashtag and a 4. Let me just enlarge this. Now to verify that we did it correctly, press this query selected node ID and see that you're actually getting some data. This updates every half a second. And we can see the time here as well, and got some descriptive data, and you can verify if the value is within the range that your configuration for ReportLoq is currently set up to. This looks fine. Data is flowing. I'll just close it again. And just for verification purposes, let's try to start ReportLoq up. We'll press save, and yes, let's try to start it. The graphic here in the background updated quite rapidly, and we can see that the CO here is generating a value. It's coming in with a 171, and this changes every 10 seconds. We can also see that it's currently valid, and that makes sense because we didn't put in any validation signals bits yet. But data has started flowing. It updates quite frequently. But let's try to invalidate it by putting in this high input 1 Boolean bit. That this should indicate a malfunction. So if I enlarge this a little bit, we can see that bit 5 is malfunction. The CO, it's possible to drag this alias column. It'll make it a little easier if you go way to the right. We want to use this malfunction column here and enter this input 1 bool. Let's try again. Notice it's not input, it's io.input 1 bool and the hashtag 4 for the namespace. And let's just query it. We've got a match. The Boolean is currently true, which is also what we can see here in the client. We'll just close it and press apply. This means that this value will now be logged along with the actual value for the data and be used for validation purposes. We could see that that actually happened. Our value is now invalid. It's in malfunction, and the connection has, this is indicating the connection has been lost. We could also see that when we queried it, it says here ACF 5000 connection lost. So you can actually use this if you're a little in doubt what this malfunction bit does in this configuration. It's also possible, and this is a little secret shared with you, to change this index to test. And if you do that, you'll see this page where you can also see the logged value coming in, and you can see that the bit has been changed. This means that you've got a bit 5 set high, and this was also the bit here, which were set high. So with the Boolean true, right? So now we can actually see that data is flowing. Let's try to put the calculation back into the to the OPC UA server. So I go back here, and I'd like to put this particular value back into the system. So we want this output 1 real to be changing. This is done further to the right. You need to go all the way beyond all those bits, and there are 32 of those. So I know it takes a little time to be scrolling. And now we've got this qual2 FLD output column. This is the one we'd like. So this is the same idea. We could put in IO dot, this is an output. 1 real at namespace 4. And you just need to notice that this PLC ID here needs to be empty. If not, data will not start flowing. So let's press apply and see what happens. It does take a little time to write the data back, because the data written back is written with the same policy as the data is stored. This means it takes 10 seconds for data to be stored, or it does store it every 10 seconds at least, and data will be written back at the same rate, and it can take a little time here for the first value to be transmitted back. You can't see this on the graphics. You'll have to use a OPC client, or actually to be logged into the OPC server to see that these data are actually written. If you're in doubt whether you've written the correct, you can see I made a spelling mistake. That's the reason. We could also try to force a value. Let's use that error and just see what happens. It says here, it's got a bad node ID. It's unknown. I don't know what to do with it. Okay, so let's put in the 1, which I actually intended to do. Let's try forcing it again. And now it opens up a dialog where I can try force a value. Let's try force 2, and actually wrote 2, right? Excellent. I'll close the dialog again, and it reverts to original state, and press apply. And data is being written here, 136. So, of course, the rate is slower because it needs to be updated every 10 seconds. So these two won't be following each other. But data will be written back to the server. We can see here now it changed to 10. So this is basically what you need to do. It's not a mandatory thing to put in these output values. It's only if you need them back in your control system afterwards, but it's a possibility to do. There's also some alarms and stuff like that, and you can even put in a watchdog if you've got a node for a date in your OPC server. We can, for example, see it here. Let me just enlarge it a little bit. We've got this input time. Let's try putting a monitor on that one. It's actually an input. I'll be using it for an output in this demo. Now we can see that this one is a strange date format, right? But I'll be using that. So it's an IO input time. It's in the namespace 4 again. And let's try forcing a value. We can actually see that it's already started to be updating. So we could force that, but there's really no reason. We can see that the date is actually changing all the time. It started pretty quickly to take effect. So now you've got a date that is being updated whenever data is being written back. 10:32:58, and let's just see if it changes here. And in 10 seconds it did. Now it's 33:08. So now you could actually add a watchdog to this input time field in your control system, and that would stop being updated if data is stopped being logged in ReportLoq, which is pretty smart, I guess, because you would need to have data in your dash system at all times. And now you can actually monitor it with another system. So just to recap, try to fill out all these orange fields. And if you wanted to revert back, let me just close it and open it again. Yeah, here we go. Try to fill out all these orange fields in the system, and consider filling out some of the others if you think there's a good reason for it. But notice that the faceplate in ReportLoq, this one that generates this pop-up, all these check marks, the validation of those are the ones in orange here. So if you put in something in this field, for example, then it'll actually make the system go into malfunction, but you won't be able to see why in the faceplate here. So if you need that data to be shown on the faceplate, then you need to contact us, and we'll change the configuration and send you a new one, and the field will then be painted orange instead. That is the way to go through with it. There are some of the bits that aren't colored. For example, these kiln and SCADA and wire break that you can set if that is actually true, and it will be taken into account if you have a wire break to do some invalidation and stuff like that. But if you needed to go on the faceplate again, then you need to contact us. Yeah, that's basically it for this demo. I hope you've enjoyed it, and feel free to send us a mail if you need further clarification. Thanks.